Okay, Bismillahirrahmanirrahim. If you can hear me, just confirm in the box. We can continue our class. Okay, the next thing we want to discuss is and that's the last part in this chapter. We want to talk about backdoors. Okay, backdoors are similar to trusts. When we want to talk about it, they have additional access rights or additional rules, but these are usually hidden, not as obvious as thank you, Hassan, not as obvious as trust. Okay, they are hardware or software based entrance to the system. Okay, they are software or hardware entrance to the system that they bypasses or these rules, they bypasses the security systems of the whatever we calculate or whatever we know that this is our security designs. Okay, it means that backdoors will allow intruders or attackers to bypass perimeter security or the rules that you already counted on, okay, or you already trusted on. The problem with the backdoor is that when the attackers they use backdoor, IDS cannot notice and also firewall cannot block because they usually don't pass through the main security doors. If we want to have the examples for the backdoors, you see, for example, you have door, okay, and then you put security guard at door. For example, you have door and then you put security guard at door. But the problem is that, for example, what if someone comes from window? You see, the security guard won't notice. Okay. So the security guard won't notice because the backdoor will come from other places. Some of the backdoors is that if a modem, for example, that you use, it's a vendor support, okay, and the vendor is compromised or somebody can just what we say forge the vendor identity, it can use the modem to enter the system or enter your or attack your system. In this figure we have some backdoor examples, okay, the backdoor examples that have been used to on that example we already had for design. You see the first backdoor, I start from the bottom of the image and then I will go to the top of the image. Let me make it bigger, okay. So the first backdoor is that, for example, a Bluetooth system or Bluetooth device can be connected to the system and to the smartphone, and the smartphone or a device can be connected to the system. As you see, it has been already connected to the office LAN, which doesn't pass through the firewall. So this is one backdoor. This is one way to connecting to the internet which does not pass through the firewall. Another one is that you can use in Farsi we say dongle Wi-Fi's, okay, we can say, or we say we use USB Wi-Fi's, okay, or USB connectors to connect one access point to the office LAN. again, if you use this Wi-Fi and you connect, we call it raw Wi-Fi, okay, or it's raw in Arabic, it's muhtal, if I'm not mistaken, okay, it's muhtal, it's not part of your design. Somebody can attach a very cheap USB Wi-Fi to office LAN. Again, you see that the communication on the all the data will go through this Wi-Fi, does not pass the security, and it does not pass the firewall. It comes from here and goes back from here. And then another thing is that because that if you have wireless communication inside your network, as you can see here, if you have wireless communication, again the wireless communication can be sniffed, okay, and they can be sniffed and close this one. They can be sniffed, and then the attacks can be happen from wireless or from here, okay, because it's already broadcast, okay, the attacks can happen from here. We will discuss this one in the next chapter, which is wireless. And also, again, a laptop or wireless device that you can bring into the local networks. Again, if this laptop contains ransomwares or contains viruses or contains I don't know, Trojan horses that can capture the data from inside the network, it creates a backdoor. Or again, you can connect this laptop to the internet or connect this laptop to the network, and again that you have a internet that passes through this laptop and does not pass through this firewall and does not pass through this firewall. So the backdoors are just look at the picture, see if you have problem or you don't understand any of them, let me know. Then yes, sure, Ehsan. You see, the first thing is Bluetooth device, okay? If you connect this Bluetooth device to the internet, and from the other side you connect it, for example, to your smartphone, and you connect to the office LAN, the traffic that comes and go from this path, they do not pass through the firewall. So you cannot protect your network from the firewall. This is one solution. Another thing is that if somebody comes and hiddenly, okay, and hiddenly installs one access point here, connects one access point to the office LAN, you see installs here, again the traffic that comes from here does not pass through the firewall. So again, it does not it won't be checked by your firewall rules, okay? And also another thing is that when you use wireless networks inside the network, maybe attacker can sniff your wireless or can attack your wireless. Again, you see this firewall cannot do anything and this firewall cannot do anything. Or if you take laptop and connect it to your private LAN, again nothing passes through this firewall because your security is your firewalls, and these traffics does not pass through Okay, this is it. Your security is your firewall, and this traffic, they do not pass your firewall. That's why. Okay. Okay. So the backdoor conclusion is that backdoors are very common in complex system because we forget some things or because of the mistakes or misplaced things. And backdoors are very dangerous because they are not based on the rules and assumptions that you have. Assumptions in Arabic. There are al-iftirazat, okay? Not based on your rules and assumptions. Okay, it means that لا تستند إلى قواعد كبل افتراضات. Okay, this one. Okay, so they are not based on the rules that you are using, but sometimes you need them and you want to make sure, you should make sure that you are aware of the risk of them. Okay, this was all thing about the backdoors and trust. So you see in this chapter we talked about, I will type in the note. Okay, we talked about backdoors, we talked about trusts, we talked about NAT and proxies, we talked about firewalls, and then we talked about air gaps, that all are part of the design for security. Okay, they were all part of the design for the security. So I should just exchange the slide to start the new chapter. If you have any question regarding this chapter while I change the slide, you can ask. Okay, I typed the answer. I hope it's clear that the backdoors, the trust, sometimes we create, okay, or sometimes we just define trust. But the backdoors, they already exist in the system, and we cannot do anything. Even sometimes when you just install one application, okay, it creates one backdoor or some malware. They create or open backdoor on your system. When you use VPN, VPN is a good example for backdoors, okay. When you use VPN, it passes the firewall, so it creates backdoor. Okay, for example, when you use VPN and you create a VPN to somewhere, it passes the firewall, so it creates the backdoor. So if throughout in the for rule we have Russia, if we have one firewall with Russia, I'm reading, but I didn't get what you said. If we have one firewall with 3 zones, up to here it's okay. The firewall making throughout in for rule we have it example. Question to most firewall have 4 rules in each case. One firewall and 3 zones. I will draw it for you. Okay, I think it's easier to answer in this way. I will draw it for you. Field. Okay, this is one zone. This is 2 zone. واحد ثاني ثالث. This is the 3rd zone. And consider this is firewall. An example you gave to us in previous lecture, okay, and give to us as okay, the rule. That one you're supposed to write it on your own, okay. But if you have one firewall with 3 zones, something like this, for example, this is in, okay, this is out or internet, and this is DMZ, okay. The number of zones that you should have is, for example, you should have in and out for this one. You see, this is out and this is in, okay. This is 2 sets, okay. And then in from internet and out from internet, again 2 sets, okay. And into the DMZ and out to the DMZ, again 2 sets, okay. So it becomes 6 sets. But okay, something which is important is that you usually never send information from internet to the inside the network and getting out. Okay, usually you don't use this part. Okay, so you only have the information. So if we remove this one, it's like that with two firewalls. You have this. The rules becomes only from local network to DMZ and vice versa. Now it's two sets, okay, and then from DMZ to the internet and vice versa, there are two sets, okay, and then you never use the from inside to the internet and going and come back. So it means that other two sets are all denied. Okay, other two sets are all denied. So they don't exist. Okay, was it clear? Okay, so this is firewall, the one firewall with actually it has 6 sets of rules, okay, but for 2 of them it's always deny, okay, from inside to the internet and from internet to the in the local network. So we only use 4 rules. Okay, this is it. So let me go back to the wireless. The next chapter we talk about, in the next chapter we talk about wireless network. Lasaliki, I think it's, we talk about in Arabic Lasaliki wireless network. No, the wireless network, the problem with wireless network is that everything that we have in wireless network, it's a broadcast. Okay, so first I will talk about the waves, okay, which are layer 1, and then we talk about the signals and frames, which are layer 2, and then we will talk about the packets and networks, which are layer 3 in the network. So first let me go to the board. I explain what is wireless and what is broadcast. Share whiteboard. A broadcast in Arabic is إذاعة. Okay. And waves in Arabic is amwaj. Okay, amwaj. So this is how wireless works. It's that usually we have one something like antenna that it creates the wave and send it through the air. So here we have antenna, okay, one antenna that it creates the wave and send it through the air. and we have something else. Okay, Hawaii, yes, exactly. And we should have something else in antenna, same design or same device. Okay, we have something else that it change the shape or give shapes to the, yes, exactly, it gives shape to the waves. Okay, so first we generate the waves, and the other one it gives shapes to the waves. It's like that. For example, if your waves is like this, okay, if your wave is like this, then you cut this part, okay, and then you do not cut the other parts, so it becomes, for example, this becomes 0, and this is 1, and this is 0, and this is 0, and this is 1. Yes, so when you cut the wave, or when you change the wave shape, it's, for example, 0, and when you don't change the shape of the waves, it's 1. Okay, so on the other side of the network, okay, yes, it's also, yes, frequency means that number of the waves at the given time. Okay, on the other side of the network, you should have an antenna again. Yes, شکل موجه. Thank you, Haydar. Yes, exactly. You should have one antenna that receives the waves. And when you receive the waves, from the shape of the waves, you can get whether, for example, so this shape is 1, and because it's already been cut, this is 0, this is 0, and you receive it and you translate it to, for example, 1 0 0 1 0, something like this. Okay, you send through this 1 1 0. Okay, yes, it can be sine waves. Yes, exactly. So you send the waves from one side and you receive the waves from another side, because to change the shape for 0 and 1. Okay, Ali, we change the wave shape to just make it similar to 0 and 1. If we don't change the shape, it's always similar, same thing. Okay, so something which is important for us in wireless is that the wireless is broadcast. Okay, even when it's point to point, for example, you send it from one point to another point, for example, from P1 to P2. Even when you send from P1 to P2, from one place to another place, still it's broadcast. It's go like, or it moves like a wave, so it goes like this. Okay, and then it goes like this. Anyone that can listen to the channel, or anyone which is here, or anyone which is here, or anyone is here, or even anyone is here or here, they can listen. They can listen. Okay, and they can sniff, and they can record. Okay, that's the problem with, or that's the main problem with wireless, because it moves as a wave, it travels as a wave, and as a wave it broadcasts, and when it broadcasts, everybody can listen, everybody can record, and everybody can change the wave or make a noise or access the wave from any place. So the concept of the wireless is like this. So this is the wave. So do not forget that we can always do not forget this one, because later we will use them and we cannot come back to this part. Okay, we can always sniff the waves. We can always sniff the waves and listen to the waves. So the structure of wireless network is that usually we will put one device in the middle. Okay, we call it with one antenna, we call it access point or AP for short. Okay, also we have the same concept access point, okay, or AP for sure, and always we have the same concept for BTS in smartphones, okay, or for cellular networks, okay, for like 3G, 4G, GSM, and etc. Okay, we also have the same thing. Okay, it's exactly it's just the access point. It starts transferring or sending signals in an area. Okay, it starts sending signal in one area and it covers one area. Okay, it's like that. When you نقطه اتصال, exactly, you have one access point. For example, also in Wi-Fi is like this. Okay, in Wi-Fi is like this. And when you have one mobile device, for example one laptop, or I don't know, one mobile device that it has antenna and it's in the range of the access point, it can communicate with access point. So the main duty of the access point is the transfer or relay information between two wireless devices. For example, if you have device A here and you have device B here, okay, device A will send information to the access point, okay, and access point will send information to device B, and B will send back the information to the access point, the reply, and then access point will relay information to A and they can communicate through the A. But when they send the information, when A send the information to access point, it's actually the communication is from A to B, okay, the communication, but because this is broadcast in the area, if I put M here, M can listen A and can listen B. If I put H here, it can listen, and if I put, I don't know, N here, everybody can listen and can sniff the communication because it's already broadcast. So everybody in wireless network can listen to anybody's signals on anybody informations that they send. Okay, so it's like this. Now we call this one access point, and several devices, and also the access point will make a connection maybe through wired or wireless to the internet. Okay, we call this system internet. Okay, we call this system, and I will type it in chat box. BSS, or we call it basic service set for wireless. We call it BSS or basic service set. We have one access point, and then we does the communication, or we transfer the communication through one access point. But usually you cannot cover a big area using one access point. For example, you have one building. Assume that this is from top view. Okay, this is the top view of your area or building. Consider that this is top view area of your area or building. You put one access point to cover here, one access point to cover here, one here, one here. Yes, Nazar Allah, thank you for helping me to transfer the information. One here, one here, one here, and then one here, one here, and then one here. Okay, this becomes the all of the yes, covering all of the area. Now you can count how many access points or how many AP we need to cover this area. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I'm not mistaken, you need 11. You need 11 access points to cover the whole area. And still you see there are some parts that we did not cover. For example, this part, you see this part, you cannot cover. This part, you cannot cover. Yeah, this part you cannot cover. You need this part, it's no coverage, no antenna, but the rest of the area, you cover the area. Now the problem is that if someone, a user, okay, wants to travel from one, for example, like this in the area, okay, consider that one user, just look at the green path, want to travel from one point to another point in the area. Something that we should do is that we should keep its connection and session. Okay, we should keep its connection and session, and that's why we talk about a concept. We call it handover, or we call it handoff. In Farsi we call it dastehi. Okay, and also in cellular network we call it roaming. Okay, we call it roaming. It means that a computer or a system, when it moves from one point to another point, we keep the connection between for that system. So because of that, we need to keep the name of all of APs same. Okay, same name for all of نفس الاسم لجميع. Okay, نفس الاسم لجميع. We keep the name for all of them. Okay, or we just put one name for all of them for users to switch. For example, in your cell phones, when you go to different BTS of the, for example, Hamrah Aval, you see something like this. This is the name. I think it's IRMIC or IRMC. Let me just check. It's IRMCI. Okay, IRMCI. You see, if you look at your cell phones, whenever you are in Iran, okay, or for Iran cell, it's for Iran cell. Let me check. It's the name is Iran cell. Okay, for the name for Iran cell is Iran cell. Okay. So when you move between different cells, for example, from here to here and then here and here, the name is same, and then they change or they move your connection to the next cell. We call this one handover or roaming. Okay, and when we have many cells that do the same thing, I will type it in the note. It's extended service set. Okay, it consists of several BSS. Okay, extended service set. It consists of several BSS. It's like that when we have many cells like this. We connect all of the cells together and then we connect them to the internet. It's like this. We connect all of them to one point and then we connect that point to the internet from all of the cells and everything. So this is the whole story, but what it has to do with the wireless security is that when you have distributed system or when you have ESS, you need to have concepts like AS means connect, okay, and you have DS means disconnect, and you have RS means reconnect. Okay, means reconnect to the same AP or move from one AP to another AP. Keep the connection and login info and etc. Okay, so you can look at the exam questions like this. What is the difference between AS association request and RS? Okay, what is the difference between AS and RS? So for association request is when you want to connect to a network for the first time. You need to log in, you need to give login information, you need to create a new session, start a new session. But when it's RS, it means that you say I'm already in the network. It says I'm already in the network and please do not ask login information again. Okay, or you no need to log in again. No need for authentication or login again. I was already in the network. Okay, I was already in the network. So we already discussed the concept of handover or roaming. We already discussed the concept of distributed system and basic service set and extended service set, and we already discussed the concept of association, disassociation, and reassociation, AS, DS, and RS. So when you move on a green line, you give okay, you see when you come to the network for a first time, for example, you come from here, okay, you need to do the association request, okay, you need to do the AS. But when you move through the network, you move from this one to this cell, you change your cell or you change your cellule in the network, this is RS, okay. And again, when you want to move from here to here, again it's RS. Now if you move from this point here, you already disconnected, and you come back here, is again AS, because you already been disconnected. And again from here to here, it's changing the cell, so it's RS. And also we call this network cellular network. You can move from one cell to another, and each time you need handover or reassociation between cells. Was it clear? Because we need these concepts to just talk about the attacks on wireless. If you have any problem understanding this, just let me know. If no, we can continue. Everybody, was it clear? I don't see anyone typing in the box. Okay. The next thing we need to understand before we go to the attacks is that, you see, when you I should go to another slide. I can keep this one. Was it? It's 70. Share another whiteboard. Okay, you see, you see, when you just turn on one antenna, okay, when you turn on one antenna in one area, or when you turn, for example, another antenna or another access point in the area, something that happens, for example, this is AP1, okay, and this is AP2, okay. When you just turn on AP1 in the area, it starts sending the signal in the area that I'm taking around this area. Okay, it sends the signal that something like I am here. Okay, it's in Arabic something like ana hana. Okay, something like that. We call this signal, it's periodically create this signal. We call this signal beacon. Okay, it says that okay, I'm here. And when you open the or you turn on the second access point, it first does the something that we call it probe. Okay, it first probes the area. Okay, for example, one frequency, it first probes the area, or we can say it first listen to the channel. Okay, it listens to the channel or it probes the area. If it receives the signals of AP1, if AP2 receives the signal of AP1, it understands that, for example, channel 1 is busy or already taken. Okay, then it will do the same thing for channel 2. Okay, again it goes to, for example, channel 2. Okay, another, for example, this is CH1, it will go to CH2 and again starts probing the area. So it sends the probe, either sends the probe or listen to the channel for beacon. Okay, it sends the probe or listen to the channel for the beacon. If there is no one on the channel 2, then it starts to broadcast its own beacon on channel 2. So it means that when you turn on your access points, for example AP1, it occupies CH1, and AP2, because CH1 was already taken, it occupies the CH2. For every probes and listen to the channel. So for every yes, for every access point or for every device that works in the area, is either the access point will create or generate beacon, or as the stations or other access points send probes to ask whether somebody occupied this channel or no. Probe to see if someone occupied this channel or no. تحقیق معرفت ما اذا کان شخص مشغل هذا القناة ام لا, something like this. Okay, they will check the channel. Okay, the last thing that we will discuss and then we will go to the attacks is that when one device and one access point start to communicate, and I draw it here, this is AP, this is computer. So If they want to communicate, the first thing is that the AP will broadcast its in the area, it will broadcast its SSID and info. Okay, it will broadcast the SSID and info. The second thing is that the computer will send AS, means request for connection. Okay, and then the AP will confirm the connection. Okay, then after this, maybe they start communicating using, for example, key and encryption, and so on and so forth. Okay, they start communicating for using key and encryption. So the first several communications are not encrypted. Okay, they are plain text. So again, we say management frame are not encrypted. I typed it in different way. Okay, management frame are not encrypted. They should be in plain text. First, they agree on what is the key, and they agree that on what is the protocol of encryption, and they agree on everything. Then start on encryption, and they start on a situation that no one can listen. So again, we talked about the props, we talked about the channels, we talked about the communications and the encryption. Then we should start the attacks. I just review the rest of the things that we discussed here on the slides, and then we will finish our lecture here with all of the concepts that we had needed for communication and for wireless, and then we start the attacks in wireless in the next class. So you see, first we say that wireless is broadcasting, and there are many or variety of wireless protocols like WPAN, WBAN, and others. We said that they work in the frequencies in different because when they don't know how to communicate, they cannot switch to the encryption only. You see, first they should say, for example, talk with each other, what is the encryption method, and then they ask, okay, what is the key, or what is the version of encryption. When they talk or they confirm this thing, then switch to the encryption. Okay, so the first thing I will give you more example later, and okay, everything is broadcasting wireless. No, everything always in wireless, it's always everything broadcast. Okay, but first, when you see a network, or you see a Wi-Fi network or SSID, you should ask it, you want to communicate, and you should ask it in plain text, because you didn't know what protocol it uses. Okay, so it's different frequencies that we use for wireless networks here, and I told you about sniffing the waves and then frequency and everything. Then we talked about access point. What is access point? Something that you put to cover one area. We talked about BSS, basic service set, when you have one access point that covers one area. We talked about extended service set. It means that you have one big distributed system that is connected to the internet. For example, here we have 4 access points that work together. And when you have ESS and you have distributed system, you need to roam between the areas that we call it handover. Okay, we talked about roaming and handover. And then we talked about association is connection between one device and one access point. Then we went to AS, DS, and RES and beacon. So AS means when you connect to one access point, DS when you disconnect from one access point, RES when you move from one cell to another cell, or when you disconnect quickly and you want to reconnect without changing the login information or without re-login and without destroying the session. So, and also we said that management frame are not encrypted, because the last thing that Ali asked, okay, management frame are not encrypted, because you know, when, for example, we want to change the language, okay, for example, when we want to change the language, when we want to change the language, first we should say hello, okay, which should be in common text or I don't know, standard text or clear text, and then say which language, okay, and which key. And then when for example we say, okay, Arabic, and then the key is and for example version 3 or version 4, then you can switch to the encrypted. It's like this. So the management frame also, they are not encrypted. Now we reach here that we start on the attacks on the wireless. We can stop here, and I can write up to here that we already finished the class. BSIM, wireless networks. I'm writing. If you have any questions, you can ask. No, Mustafa, only homeworks. If I gave you homework, you can do the homework. No. And this is it. Any other questions? Okay, thank you. Sorry again for delaying in starting the class, and thank you for your patience. Thank you for attending the class.